trying to find an equation for this function graphed. So I'm going to start by saying, well, that looks an awful lot like an exponential equation. Based on the upward curve and the asymptote at the x-axis, I would classify that as looking like the exponential functions that we've studied. And then I might make myself a little table of values. X, y, and I would say, all right, when x is -1, y looks like 1.5. And when x is 0, y is 3. And when x is 1, y is 6. And then I would try to see if I can find some kind of pattern among the y values. And knowing that exponential functions are, the definition of an exponential function is that you are repeatedly multiplying, I'm going to look at those y values and say, oh, look, to get from 1.5 to 3, that's times 2. 3 to 6, that's times 2. If my conjecture here is right, then when x is 2, y should be 12. And it does, in fact, look like 2, 12 is a point on the graph. So a general formula for an exponential function is b to the x. And the base is that number that you're multiplying by over and over again. So my equation here is going to be y equals 2 to the x, I would think, except when I plug a 0 in here, 2 to the 0 is 1 and not 3. So I actually have to do a vertical stretch of this 2 to the x. So if I were to make a table of values x, y, for just the equation 2 to the x, I would go -1 is 1/2, 0 would give me 1, 1 would give me 2, 2 would give me 4. Right? All right, so now I compare the y values in my 2 to the x to the y values in my function that I'm trying to find the formula of. And how are they related? 1/2 to 1.5, 1 to 3, 2 to 6, 4 to 12. Well, it looks like the y values in this mystery function over here are 3 times the y values of y equals 2 to the x. So in fact, my equation is y equals 3 times 2 to the x. We have 2 to the x, but with a vertical stretch by a factor of 3.